So let's zoom in. Alright, so for today's tutorials, I'm going to go over all the 3 graphs that we learned all week. So we focused on potential kinetic energy. We started with position time graphs, distance time graphs, and speed time graphs. Alright, so this is a position time graph. And the only thing the difference between a position time and a distance time is that the position tells you where you are. So if you calculate the speed on a position time graph, the slope of the line is velocity. And we should know that velocity is speed plus what? No. Velocity. Speed tells me what? How fast. Velocity tells me how fast, and acceleration tells me if I change directions or if I sped up or slow down. Velocity is speed with direction. So at the beginning of this lesson, we talked about reference point and displacement. The reference point is where you start from. The displacement is how far you are away from the reference point. And that's one thing that we were confused on the test when they asked what is the reference point and what is the displacement. So let's just look at this graph. We're not going to do this worksheet, just look at the graph. So where is this person starting from? 0. So the reference point for this entire trip is what? 0. Okay. The displacement is how far the person is away from where they started. So when the person gets to B, what is their position? Huh? The position is 6, and how much time did it take them to get to B? 2 hours. So right here at B, what is their displacement? How far are they away from where they started? 6. They're 6 meters away from where they started, and they've also moved 6 meters. What kind of speed is this line? This is constant speed. Alright. Now from point B to point C, the position started at 6 and it ended at 6. Did this person move? No. So what do we say about this line? At rest. So if I wanted to calculate the speed of this line, what would it be? It would be 0. Okay. C to D. So at C, they started off at what? 6, and they went down to 4. How far did they move? They only moved 2 because they started at 6. So they only moved 2. Now they're at 4. How do I get the distance for this point? Oh, okay, so you're actually calculating it. Okay, so I like that. That's what I would do on a speed time graph. But if I look right here, I want to get the displacement. Displacement, again, is how far they are away from where they started. How far away are they from 0? 4. So the displacement is 4. But I walked up to 6, 0, and then 2. But my distance is 8. So this is like you leave your house, you walk to the store, you stay at the store, and then you walk to a friend's house. Your distance is how far you went for the total trip. But your displacement is only how far am I away from home now? Well, I'm only 4 miles away from home. Even though I walked 6 miles, I also walked back 2 miles. Does that make sense? What's happening from D to E? At rest. So what's my distance there? 0. E to F is constant speed. Yes, thank you very much. If I started at 4 and I walked to 6, how far did they walk? 2. And then lastly, well, second to last, what's happening at F to G? At rest, so what's my distance? And then lastly, G to H. I went from what to what? I went from 6 to 0. So on a position time graph, there's no acceleration unless it's curved. So on this graph, it'll be returning home, remember, or going back. On a DT graph, it would be constant speed. But on a PT graph, this is going back, because remember they started at 0. So for example, the story for this one is Jesse goes to work. So Jesse leaves home and he goes to work. He works, so his distance is not changing. He goes to lunch. He eats lunch. He goes back to work. He works for a little bit and then he goes back home. That is a PT graph. If I wanted to get the speed of this graph, I need the total distance over the total time. So I would add 6 plus 0 plus 2 plus 0 plus 2 plus 0 plus 6 and get its total distance. And how much time was this entire day for Jesse?
0.
How much time? 11. 11 what? 11 hours. So it took Jesse 11 hours to go to work, go to lunch, eat lunch, go back to work, and then make it back home. Any questions on PT now? Okay. This is the same thing as a GT graph. The only other graph that we spent time on was a speed time graph. A speed time graph tells me how fast I'm going. That is it. And we looked at different graphs. So on this graph right here, look at the speed. My speed was 0, then it's 2, then it's 4, then it's 6, then it's 8, then it's 10. What's happening to my speed for this line? Huh? Is it constant? But I went from 2 to 4 to 6 to 8 miles per hour to 10 miles per hour. What's happening to my speed? Yes, this is acceleration. On a PT graph, we said that was constant speed. And let me show you why that's constant speed. Because at each point, if you divide the distance by the time, the speed is the same. Okay? So this is constant speed on a PT. This is acceleration on an ST. You have to know the difference between the two. Okay? Now, right here, what is my speed? Huh? It's constant speed. It's not 0. Look right here. It's 10. So what kind of speed is this? This is constant speed. Because the speed stays the same. You did this one already. I'm just referring to the graph to show you.
It's a different graph.
So from here to here, my speed was at 10, then I went down to what?
You went down to 50.
Then to. So what's happening to my speed right here?
D6.
All right, so it can be acceleration or deceleration. It's slowing down. All of those are fair games. But I go all the way down to 0. So what happens here? This is at rest. Why was this not at rest?
Because it didn't touch the time.
Because the speed is the same. It's staying at 10. This is not at rest, but right here, why is this at rest? Because it's position time. My position is not changing. Very well done. Okay? And this would be at rest. Are we seeing the difference between the two? Okay. Let's move to this. So what does acceleration look like on a DT graph? A curve. Very well done. What does constant speed look like on a DT graph? Very well done. A straight diagonal line. And then what does at rest look like? A straight what? A straight line. Does that have to be at the bottom? It does not. Very well done. It can be anywhere. Now, speed time. What does acceleration look like? Oh. Doesn't have to be. Is it diagonal? You're right, girl. Don't guess yourself. It's no second guess. It is diagonal. What about for constant speed? It's a straight line again. Notice that it's not this anymore because my speed stays the same. So you know what helps me out? I do this. 0, 1, 2, 3, 4, 5, 6. What is my speed for this whole line? 4. Now, if I put numbers right here, every time my time goes up, what's happening to my speed? It's accelerating. So you may need to put numbers by it until you get really good. Okay? Now how do I draw at rest on an ST? Very well done, because my speed is going to be what? 0. And these are all the same as which one? Distance time. Are you ready to move on? Okay, let's do this one together. Analyzing motion graphs. So I think all of us have to redo this one. Galen, baby, get your paper. We're gonna start. You do. It's right on your shoe.
Oh, I thought you were talking about that.
Okay. So I'm gonna zoom in a little bit, and then I'm gonna do this one with you. What is happening at segment C to D? So let's find C to D.
Constant speed.
Okay. It is constant speed, and tell me how you know.
It's going up. It's going up. But it's staying.
How would you describe that line? Diagonal or horizontal? It is a diagonal line. So do we agree that this is constant speed? Okay. Question 2 says, what is the speed from 8 to 12 hours? What's our formula for speed?
Distance over time.
Very well done. Speed equals distance divided by time. Did they give me the distance? But they gave me the what? They gave me the time. What was my time? If you had to run, if I told you you have to start running at 8 and you can't stop running until 12. Yeah, 4 hours. So I know that it's difficult when I say you went from 8 to 12. Always put it in something that you can relate to. Because every time I say you have to run from this time to this time, oh, I bet you everybody knows how long they have to run. So the time is 4 hours. And now I need my distance. So at 8 hours, what distance was I at here?
3.
I was at 3. So I'm starting at 3. I'm just going to write that right here so I know I'm starting at 3. And I went until I got to 12. Now what distance did I get to? 12. If you started running at 3 p.m. and you didn't stop running until 12, how long did you run?
4. Oh, no.
Try it again.
Who runs for
It can't be 12. You ran for 9 hours. Because you started at 3 and you ran until 12. Does that make sense to everybody? If not, it's okay. Another thing you can do, all you have to do is subtract. 12 minus 3 is 9. I'm sorry, I didn't do it in my calculator. I didn't do it in the screen. 12 minus 3 is 9. Or just think about it. If you started running at 3 p.m. and you ran until 12, you ran 9 hours. 4, 5, 6, 7, 8, 9, 10, 11, 12 is 9.
I messed up on it because I thought it was 5.
Okay. So from 3 to 12, my distance is equal to 9. So now I have distance and I have time. So what do? Go back to your formula. What do? I divide what? 9 over 4. And what do you get? Should be 2 point something, but I'm not going to tell you everything. 2.25 is correct. I'm not going to worry about number 3. I'm going to skip number 3 and I'm going to go down to 4. What is the speed of the line segment? What I noticed that everybody did when they did this, their time was 20. But what segment am I only focused on? E through F. I'm only looking at E through F. Okay, what's the formula for speed? All right, write my formula. Now I need my distance and I need my time. For E to F, what was the distance at E? 12, and you went all the way down to what? No, you went down to 0 for distance. You looked at the hours. But you started at 12, look right here at 12, and then you went down to 0 here. Does that make sense? Okay. So if you started at 12 and you walked to 0, how far did you walk? 12. So my distance is 12. And now here's my time. I started walking at 14 hours, and I didn't finish until 20 hours. How many hours passed? 6. So I have my distance and I have the time. So now all I'm going to do is plug it in. S is equal to what? What goes on top? What do I put on top? 12. And I divide by what? 6. So my speed is what? 2. Alright. Number 5, what is the average speed of the total trip? So if you need average speed, that is equal to my total distance over the total time that it took me. Now you have to calculate the total distance. How far did this person go? They walked to school, they stayed at school, they went to a friend's house, they stayed there, and they walked all the way back home. You need to know how far they walked for the whole thing. How far did they walk from A to B? From 0 to 4. What, 0 to 3, I'm sorry, that was 3. What did they walk right here? 0. From here to here? No. 3 to 12. 9. What about here? 0. And then they walked back home 12. Add it up. 24. So my distance is 24. And how long did it take Billy to do all of that? 20 hours. Find my average speed. I'm going to give your papers back tomorrow. And you can see the mistakes that you made. Because most of us missed like 11 on this. 11 out of 15. I had a lot of 7s. Like just 7 out of the whole grade. So we're going to look at, I want you to compare what we did together versus what you got. Is that all about motion you have? Do you need this one that I'm working on? Oh, can you show him the All About Motion YouTube link? Okay. Okay. So what was my average speed?
1.2.
Yes? Huh? Joaquin needs a, yeah, so he can do that worksheet with me on my YouTube. All right. Next graph, but what kind of graph is this time? A speed time. So let's find segment B. What's happening here? What speed am I going? It's constant speed. But how did you know? It's a straight line, and then my speed stays at what? 15 for the whole trip. So number 7, what is the speed of segment B? What did we put? No. When it says what is the speed, it always needs a number. 15. I noticed that a lot too, that people put a description instead of the actual speed. What is the distance traveled at 30 seconds? So, what is my formula for speed again? Another thing that you can use is what? What do we always draw? The triangle. So speed is equal to D over T. Okay. What am I solving for in this one? I'm solving for distance, and I have time. So if I cover up distance, what am I going to do with the speed and the time? Multiply. So my new equation is distance is equal to what? Times time. Okay. So we have our time. How do I find my speed? What's my speed at 30 seconds? 25. So I'm going to do times what? 30. Very well done. Who got that the first time? Look at you showing out. She may have. What's happening at segment B? It is acceleration. Why is it not constant speed? Thank you, baby. Okay, can you give me another one out the basket? Out the bin, on Tuesday? Okay. And so you can have that one, I can have one to write on. So it is acceleration because what's happening to my speed? It's decreasing. Very well done. So you can put acceleration, deceleration, you can put slowing down. All of that would be fair game for D. And we're not going to worry about number 10 because we just did the same problem right here. So I'm not even going to grade that one when you turn it in. This one for the bottom, what kind of graph is this? This is a PT. So it shows where you're going and where you started from. Did you not see it? Only have one in there? It does. Bring me the Tuesday folder. They're in front of the other papers. He's looking for a calculating speed, what I'm about to do next. What's happening at C to D, guys? It's at rest because you started at what position? And you ended at 15. So you did not move. Now, a lot of my kids, I only had like 2 kids get this one right. What is the displacement at 4 seconds? Well, you have to know where you started from. Where did you start from on this one? You started at 25. So I'm just going to do start equals 25. At 4 seconds, where were you? You were at 15. Okay, keep that in your mind. At 4 seconds, you were at 15. I know. Here. At 4 seconds, we were at 15. So if you started at 25 and you walked to 15, how far did you walk? All of my kids put 15, but you started at 25. What was your change in distance? 10. You only walked 10 meters. You did not walk 15. So a lot of y'all did this. Okay, 4 seconds, boom, 15. I'm at 15. But you started at 25. You didn't start at 0. Okay? What's happening from D to E? You can put slowing down. You can put constant speed. I wouldn't put slowing down because it's not speed time. I wouldn't put going back home because home is up here. Does that make sense? Okay. I'm not going to worry about 14 because we just did one like that. And then G to H, calculating the speed. That's a good question. So I'm only going to focus on G to H. What I noticed a lot of my kids did, they did the speed of the speed of the whole line, the average speed. If I only look at G and H. At G, what is my distance? I'm already at 15. And how far did I walk? I walked to 30. But what was my change in distance? It wasn't 30. 15 plus 5 is 30? Okay. So wait. Let's back up. If I start at 15, if I told you have to run from 9:15 to 9:30, how long did you run? 15 minutes. That's the same thing. If you started at 15 and you walked to 30, you only walked 15 meters. Is that making sense? Yeah. Okay. So my time is not 30. It's actually what? My distance. I'm sorry. My distance is 15. Now I got to get my time. If I started walking at 9 and I walked to 11, how long did I walk? 2. So what we should have did was S equals 15 over 2. And a lot of us did 30 over 2 and got 15. But the answer was 7.5. Is that making sense? Okay. All right. Any questions on this one? So this is all 3 graphs. The next one that we need to look at is calculating speed practice. This is our last one. I'm going to zoom out a little bit. Yes, baby. Right here. Oh, yes, right here. This is all my work I need to regrade. Do you need a pass to get a badge? Okay, I'll just write one just in case. Do you need this one? No. Okay, so you need the YouTube video for that one. Yes, I already recorded that one. Here you go, Bree. You're welcome. Carlicia, once Dalen gets signed in, can you show him how to get to the YouTube link? Or Dalen, do you know how to get to it, baby? You know how to get to it? Okay. Okay. Do you have? Okay. Can I write that? Can I write it down and you can take it home to look at it? Okay. Right here. Work. I need to regrade. Guys, if you're turning in that paper I just did for your higher grade, you can turn it in right here because I'll take what you did with me. Yes. For me, I'm gonna finish as soon as I finish this handout. But tutoring doesn't end until 4:30. But I end at about 3:45. Yes. Right here. No, I'm gonna do this one right now. But the All About Motion, you can do it on YouTube with me. Okay, I just did this one. I'm about to do that right now. Yeah, guys, I need to continue though. I need to keep going. So if you need to go to you need to go somewhere, just leave the door open. Okay. So if you need to do calculating speed, I'm about to do that right now. Yeah, I gotta keep going. It's easy. Okay. In the first one, here's the instructions. Okay, so this one says calculating speed practice. We have to write the equation, plug in our variables, and give our final answer with the units. The first thing that I want you to write is your triangle, because that'll help you solve for those equations. Solve for the variables, I'm sorry. So S, is equal to D over T. Do we have that part? Okay. If I cover up D, I'm solving for D. What do I do with S and T? If I cover up T, what do I do? Divide. And if I cover up S, what do I do? Be ready. Okay. A football field is about 100 meters long. 100 meters long is my what? That's my distance. If it takes Mr. Holden 30 seconds to run its length, how fast is he running? 30 seconds is my what? Time. And when it says how fast, what am I solving for? Speed. So I'm solving for speed. So in the equation, I'm going to write S equals what? D over T. Plug in variables. That means you write S, but now you're going to plug in the numbers that you have. What's the distance? What's the time? 30. I'm sorry, does that make sense? Okay, so then all you need to do is do 100 divided by 30. What we get? 3.3. What's my units though? Meters per second. Meters per second. Any questions on that one? Okay, let's look at number 2. If the pitcher's mound is 85 meters from the plate, the pitcher's mound is 85 meters from the plate. What is 85 meters? Distance. It takes 30 seconds, what's that? For Miss Hollenbeck's pitch to reach the plate. How fast is her pitch in meters per minute? How fast is what? Her speed. But what does it want it in? It doesn't want it in seconds anymore. It wants it in minutes. 30 seconds is how much of a minute? 1/2. As a decimal, what's that going to be? 0.5. So I want to make sure that I use 0.5 minutes and not seconds. I'm solving for how fast again, so my formula is the same. My equation, S equals D over T. S is equal to, what's my distance? And I divide by what? No, 0.5. Alright, so S is equal to, should be 170, 85 double. And what's my unit? Meters per minute, not seconds, because it wants the answer in minutes. A lot of my kids did 85 divided by 30 and got the wrong answer here. Okay? This one, the verbiage is wrong. Every summer, Mr. Rose drives to Michigan. It is a 3,900 kilometer. It is 3,900 kilometers to get there. What's that? If he averages 100 kilometers per hour, what's that? No. That's the speed. How much time will he spend driving? What am I solving for this time? Time. Look, how much time? I don't have the time. So if I cover up t, what am I going to do with d and s? I'm going to divide. So my equation is not s equals d over t. I'm solving for time, so my equation is t equals what? D over s. Very well done. It's clear. Very well done. Now I got to plug in my variables. T is equal to what? 3,900 divided by 100, which will be 39. And I'm looking for time. Is it kilometers or hours? Hours. Do we see where we went wrong on this paper? Okay. Any questions? Okay. A helicopter flies 20 miles in 2 hours and 30 minutes. Okay? 20 miles is my what? Distance. It says 200 miles. Oh, I'm sorry. 200, I'm sorry. Look, I've been teaching all day. I'm tired. In 2 hours and 30 minutes. What's 2 hours and 30 minutes? Calculate the speed in miles per hour. So what do I have to do to my 2 hours and 30 minutes? Wait, hold on. It's in minutes. How do I change 2 hours and 30 minutes? Yes, 2.5 what? Hours. You're right. 30 minutes is half an hour. So my time is going to be 2.5 hours. Not 2 hours and 30 minutes, because 30 minutes is half of an hour. 2 plus 0.5 is 2.5 hours. If it was 3 hours and 30 minutes, that would be 3.5. So what am I solving for? Look, calculate the speed. So my formula is what? S equals d over t. What's my distance? And I divide by what? 2.5. Huh? 80. So my speed is 80 what? Miles per hour. Very well done. Alright, last two. A runner ran for 3 hours. What's 3 hours? A time. At a speed of 40 kilometers per hour. So what's that? 40 kilometers at a speed of speed. What is the total distance? Okay, so I'm solving for distance. If I cover up D, what do I do with S and T? Multiply. So what's my formula? D equals what? S over T. If it's side by side, you multiply. S times T. D equals S times T. Okay. Plug in the variables. So D is equal to, my speed is what? 40. And what's my time? 3. What was my distance? 120 what? Kilometers. Very well done. In a competition, an athlete threw a flying disc 139 meters. What's that? That's the distance through the air. While in flight, the disc traveled an average speed of 13 meters per second. What is 13 meters per second? How long, what am I looking for there? How long did the disc remain in air? That's a time. So if I'm solving for time, if I cover up T, what do I do with D and S? I divide. So my new formula is T equals what? D over S. T equals 139 over 13. T equals what? Hi, baby? 10.6. What's my units for time? What's the S? Seconds. Do we have any questions? Is it making sense what we did wrong? The only one that I do want to look at these. I changed my mind. Calculate the speed at 30 seconds in meters per minute. So I want the speed. What's 30 seconds? That's my time, but I want it in minutes. So what do I change it to? 0.5. Half a minute. I know what you meant. At 30 seconds, what is my distance? 20. So S is equal to 20 divided by what? By 0.5. S is equal to 40. Calculate the average speed from 0 to 20. So if I'm looking from 0 to 20, that means I went from here to here. So I'm only focusing on this part of the line. Do we understand that part? So in order to get the speed, I need the what? The distance and the... What goes on the distance? I want to get speed. Distance divided by what? Time. What is my distance from 0 to 20? How far did I go? Y'all don't have this paper? Oh, you did the other piece? Okay. My people that are doing this with me, how far did I go? I didn't go to 14. I went to 13. Now my time is 20. It took me 20 seconds to do that. So all I need to do is do S is equal to 13 over 20. Alright? This one was pretty easy. What is the starting position? Where did it start? No, it didn't. It started at 20. It didn't start at 0. So it started at 20. What is the displacement between 0 and 3? From 0 to 1, how far did you go? 0. You started at 20 and you ended at 20. Did you move? That's a straight line. Now at 1 to 3, how far did you move? You moved up to 60, but you started at 20. Therefore, you only moved 40. 60 minus 20 because you were already at 20. It can't be 60 because you didn't start at 0. Does that make sense? The other one that I wanted to look at, you can cross out all of these. I won't grade them for you. Using the graph below, determine which segment is the runner at constant speed. What kind of graph is this? ST. What's happening at segment A? Acceleration. Because you're speeding up. Look, 0, 1, 2, 3, 4, 5, 6, 7. The speed is going up. What's happening at B? That is my answer. What happens at C? Very well done. And what happens at D? No constant speed on this one. That's acceleration. So my answer for constant speed was D. Alright, I'm going to stop there.